So good evening, everyone, and welcome to this session. So today's session is about automating and virtualizing the networks with the multi-service VXLAN Fabric. I think everyone would have heard these words or already have done some implementation of an automation or virtualization, the networks running a multi-service or with VXLAN, right? So today's session is more about how we are going to put it together and give you a thought process to see how you can change your network or take an approach where we will be actually discussing about an abstraction of overlay and an underlay and see how it can actually benefit your services that you actually offer. So I'm Vanesh Kesavaraj. I'm a principal network architect with Pluribus Networks. So let's actually get into the agenda. So if you see the agenda, I think we will start with addressing some of the challenges, what you have in delivering your current layer 2 and layer 3 services in a Jio distributed manner. So we will see some of the challenges. And then we will talk about an approach which gives you an option to work on a flexible topology as well as agile delivery and independent transport. And be fitting in different architecture, like it can be a service provider, it can be a metro, it can be a data center, it can be IoT. So where the solution can actually fit in different architectures. And then we will see like how we have implemented a layer 1 or a layer 2 or a layer 3 services using a overlay architecture or an IP underlay. So we will see like how we have actually implemented. So let's actually talk about Jio Distributed Services, right? So when you talk about Jio Distributed Services, some of the major requirement that actually comes in is like delivery of your point-to-point circuit, multi-point to multi-point, L2 VPNs, L3 VPNs. So these are all the services what the business is actually driving, right? And one of the important concern is, okay, how are we going to geographically scale, as well as how we are going to do a tenant scalability as well, right? Because you don't want to build a network that is going to be only supporting limited customers. So you need to have a scalable network, right? And the design should as well support it. And another important thing, what we actually see here is how are you going to deliver using generic IP transport rather than having an MPLS or some advanced costing features which needs to deliver some basic services. So here we are actually going to see like, okay, how we can address the challenge of, okay, how we can deliver using an IP transport. Another important thing is from an orchestration perspective, right? So how you can simplify the orchestration, because earlier the delivery team used to do the entire orchestration for the customer. But nowadays the market, what it is actually demanding is, can the orchestration piece be given to a customer directly, so that the framework should be simple. So customer can on demand, he will be able to implement the services like increasing his bandwidth, lowering his bandwidth. And if you have a backend system supporting it, then it actually makes the job easier for the customer as well, right? So that's where we are trying to see like how we can actually address the challenges, right? So when we actually talk about so everyone knows, like, because the services, whatever we actually mentioned, it is already offered, right? Because it is getting offered via traditional layer 2 fabric or a layer 3 fabric, right? Which we'll actually talk. These are all something which is currently getting offered. So when we talk about layer 2 fabric, it is really easy, manageable, it is easy to automate. So we are actually good when in terms of automation, right? But when you talk about multipathing, I think it is not purely efficient to deliver all the services. And when we talk about a geographical scale, as well as in terms of a tenant scalability perspective, we have some challenges with the traditional layer 2 fabric. So next, let's actually get into some of the modern layer 3 fabric, which is currently in production, right? Because the services are already offered, right? So when you think about a layer 3 fabric, it actually works good in multipathing, geographical scale, because the current internet works on layer 3 fabric, supporting 1.2 million routes, spanning all geographies, spanning multiple service providers, right? So in that way, from a scalability perspective, we are actually good. But when you talk about an orchestration, as well as in terms of the features required to deliver the services, you need like IP tunnels to be configured. You need to have some additional protocol to exchange of routes in making sure the traffic is actually properly exchanged. And when you talk about a bigger network, it is actually going to have a heavy control plane traffic, which is going to have a limitation on the number of scale, how much customers can be deployed, right? So now we see like, okay, when you want to geographically deliver a service, we have such challenges when we deliver using a L2 or a L3 fabric. So now let's actually move or give you a thought. If I'm able to abstract my network into two different portions, right? So like I actually do something like overlay as well as actually as an, can you actually go to the next slide, please? Yeah. So if you are able to, so if you are able to split the network, so this is an abstraction, like if you are able to kind of split the network into two portions, one is your underlay as well as actually your overlay, where when we talk about your underlay, I think this is what we have been doing for years, right? We know how to actually run a complex network, or we can actually build a high available network. So we know things, right? So we can split like underlay. One time you actually provision it, you are not actually going to touch it at all. So that we actually get a benefit of a strong underlay with full availability, and you touch it when you need to do some augmentation or some capacity addition. That is when you are actually going to touch the underlay network. So next, let's actually talk about the overlay, right? So the challenges what we actually had was, okay, how are we going to deliver the services in a very agile manner, right? So if I'm actually going to build a overlay with the concept of SDN in addition, let's see like what are the benefits we are actually going to get, right? Because when we talk about overlay, I just need to make sure I have IP reachability, right? So I don't need to worry about what topology I'm actually in, what is a transport underlay. I just need to make sure I have a IP reachability, right? Because VXLAN is nothing but an overlay protocol, which is actually going to encapsulate your layer 2 payload in an IP packet, and it is actually going to use UDP for the transport, right? So with VXLAN coming in one new addition, what needs to be done is you need to make sure your underlay supports jumbo frames, because there is a 50 byte header that actually gets added to the VXLAN, which VXLAN actually adds it. So you need to make sure you have a jumbo MTU enabled on your network, or supporting a 1600 bytes in minimum, right? So that's the only requirement that needs to be done on the underlay. But when you talk about your overlay, that is where your services provisioning actually comes in, where you can actually, your daily services, what needs to be provisioned on day one, or you actually do it on a day two, like whenever your customers are actually going to come in, that is where the provisioning actually happens on the overlay. So you don't touch your underlay at all, right? And when you talk about, now we are able to use the overlay with VXLAN coming in with topology differences or topology independence, and using your IP transport for the communication. Now let's actually jump in to see like how we solve the problem of automation or orchestration or quick take it to market, right? So that is where SDN is actually going to be coming into picture. Okay, so when we talk about SDN, there are two architectures that is actually currently available, right? And when you talk about SDN, the industry is more oriented towards a centralized controller. But what we actually think is a distributed controller might actually fit in more when you actually go for a more of a geographical scale. A distributed controller can actually fit in more, because there is no external controller in a distributed controller model. So if you see the slide, the switches which is actually forming the fabric, these are all the open networking switches, which is actually going to have an operating system running on top of it. And each switch acts like a controller. So that is how we are able to achieve the distribution across wherever the switches are actually deployed. The switches are actually going to act like a distributed controller, right? So thereby, you don't need to actually worry about an external controller to control my network. The switches which is actually running the operating system will function as it is, right? Because the switches actually has the layer 2, layer 3 functions to perform. In addition to it, the operating system which is actually going to run on the switch, it's going to act like a controller and make sure the communication is all actually happening, right? So this is where, if you actually consider, you actually have a benefit of when the fabric formation need to actually happen, I don't need to have an external controller to control it, right? Because when you talk about centralized controller model, I need to have an external controller to configure all things, right? Here, the operating system, which is going to be running on the switches, they are actually going to communicate with each other, and they are able to form a control plane communication, and all the switches act like a single switch. or act like a single controller. So when you want to do some configuration, you just need to configure any switch, the entire fabric will be actually configured. So that's where you actually get a benefit of using a distributed controller, because you don't need to worry about a topology, you don't need to worry about the transport, underlying transport. It just needs IP reachability, so that all the controllers can actually communicate with each other, and you can configure any one of the switch in the controller, and the entire switch network will be actually configured. So that's the benefit what we see when we actually want to go to multiple geography, where I don't need to kind of provision a controller in each and every location, because when I need to consider about a scale, I just need to make sure I have my switches in place, so that I'm able to have a network which can drive a scale with the number of switches what I'm actually going to deploy. So with the distributed controller getting a good advantage over a centralized controller in a geographical scale perspective, let's actually see like what services we have actually implemented, right? So one of the first service what we actually are going to talk here is like the most important thing is actually your point-to-point circuits, right? So the point-to-point circuits are actually going to be delivered as an overlay service using the same open networking switches, which is actually running the controller function as a part of the operating system. And here the benefit what we are actually going to do is it is going to be fully transparent. And in case if there is a link failure on one side of the network, the other side of the network will be able to know with the help of the link state synchronization. Thereby we are able to prevent any kind of blackholing, right? Because if the customer is not going to run any kind of protocol, then it results in blackholing, because I will not know like whether the other side is actually down, because it is not a direct point-to-point link, right? So with this L2 VPN service, which is actually offered over the fabric without any kind of external controller, we are able to achieve the link state synchronization. As well, we are able to prevent the blackhauling for the customers. So the next service what we actually are going to talk about is your ELAN service. When we talk about ELAN, the earlier scenarios, right? Usually customers come with the .1 queue on one side, other side it will be a .1 queue, so that they will be able to communicate. And the other side can be a QNQ, other side will be QNQ, they will be able to communicate, right? But nowadays the requirements have actually totally changed, where customer actually wants a model like, okay, in one part of the network, I will be connecting as a QNQ port. In another part of the network, I will actually connect using a .1 queue. In another part of the network, I will just connect as UNTAC. But I just wanted to make sure all three locations are able to communicate with each other, right? So that is where we have actually implemented this point-to-multipoint service with the ELAN concept. And without a controller kind of design, we are able to implement more than 8,000 L2 VPN services on the entire fabric. And with E3 service is your distribution model, right? Where the spoke locations needs to only communicate to a centralized location. The spoke location should not talk with each other, so that you are able to provide end-to-end security. That is where the E3 service is actually going to play a role. And E3 service plays an important role in IoT, right? Because when you talk about IoT devices, they should not talk between each other. They just need to talk to a centralized location, right? So this service can be implemented using the E3 feature, which actually follows the MEP standard, and this can be implemented across the fabric. And this is something without any kind of external controller. So the switches which is going to be running as a controller, that's how it's kind of like implemented, right? And we also support the active standby as well as active features as well. And the other next can you move on to the next slide, please? Yeah. So the other service what we deliver or what we have actually implemented is a layer 3 VPN service. So this service is going to be running on the same network, which is actually going to offer your L2 VPN like ELAN or ELINE using the same fabric, and without any kind of external controller, we will be able to deliver L3 VPN services, or we have implemented L3 VPN services. And this does not need any MPLS in the background. You just need to have an IP network, which is actually your underlay. And on the overlay, we will be able to do a distributed VRF across the fabric. Thereby, we are able to provide full end-to-end segmentation. And when a provider is going to offer a shared service in terms of like management, or in terms of like service layer components like firewall, we will be able to do inter-VRF communication, so that customers can utilize the shared service, but in terms they can also manage the same security, because they cannot talk with each other, because each one is going to be under a separate VRF. And we can actually do close to like 4,000 VRFs on the entire fabric. Thereby, we are able to achieve the layer 3 VPN services. And these are all something independent of what is your underlay, right? Because I just make sure my underlay is built to make sure I have an IP connectivity. And using your SDN, without any kind of external controller, we are able to offer all the services. So to summarize, I think we started with the Jio Distributed Services, where we actually had discussed on the pros and cons. And then we had a thought of, okay, can we take the network into a different way of abstracting into an overlay and underlay, with underlay network running your traditional routing protocols and overlay with VXLAN, with just an addition of jumbo frame into your network to support the additional 50-byte header. And then we went into to see like how the orchestration as well as quick delivery can be actually solved in terms of bringing up the services across the overlay fabric using a distributed controller model, considering you want to move to scale to different geography. And then we saw like what are the different services that can be run across the fabric. Using the single fabric, we were able to deliver your mesh standards like E-line, VLAN, and E3, and L3 VPN services. So the message what I want to give on this talk is to make sure when we are able to abstract, we get the benefits of your strong underlay, and the amount of services that can be actually run on a topology independent as well as a transport independent network. So this is what I actually wanted to convey, and I'm open for questions. Thank you.
Well, thank you very much, Vanesh. Well, actually, there were no questions on the chat asked, so I assume everything was quite clear. So thank you again for this presentation. Hopefully, next year we will see you here in Amsterdam.
Sure.
Okay.
Sure. Thank you. Thank you.
Bye.
Thank you.